Well, hello everyone. I think we'll get started today. Good afternoon, good morning, good evening, wherever you are. Just making sure everything's set up here, ready to go. We've got most of our attendees starting to slow down their login, so I think we'll get started. So today's topic is Introduction to ShipConstructor Hull. I'm Norman Eldridge. I'm the Senior Product Manager here at SSI. And this is all part of a webinar series that we've been doing and we're going to continue to do throughout this year. The agenda is basically, a format is they'll do an introduction. Really the focus is the demonstration. So I want to get over this introduction fairly quickly. I think most of you, according to your login surveys, are somewhat familiar with this product. Audience primarily intended for users, your designers, and the managers of those users. So this is intended to be a technical demonstration. Really we're going to cover the key features and some best practices and that kind of thing. Key takeaways, up-to-date awareness of the product, benefits, practices on how to use the product, and of course just general awareness. We will be accepting questions and answers during the session. I will say though that because of the number of attendees, we probably won't be opening up the microphones. There is a question or chat capability within the GoTo interface. I'm sure you're all familiar with it. If you could enter your questions there, we'll be happy to answer them. Please try to keep on topic with what's being presented at the time, just so we can get through our demonstration effectively. And if there's more questions, will certainly be opportunity at the end of the session, as well as after the session, of course. I will introduce just a few polls during the session today, just to get a better idea of who we are talking to today, and so you're also aware of the rest of the audience. Our product demonstration today will be by Zoe Fife, Technical Product Manager. And Kevin Van Donkersgood will also be available for questions and answers. So it's lead software development with Hull. So this gets me to my first poll. Just bear with me as I open it up. We would like to understand which ways we're able to get or reach out to you and make you aware of these sessions. So if you can see here, there's a poll in progress. If you could take the time to just quickly check which one applies to you. We'll just give it a minute. That's great, everyone. You'll be able to see the results when I close it. A nice feature of GoTo webinars actually is I can see the votes as they're coming in, and I can see if everyone's voted or not. Okay, we'll close the poll. I'll share it with you. Looks like most of you are contacted through our marketing emails. That's great to hear, as well as a bunch of you come through the Nexus Bulletin notifications. It's also good to hear, and we'll see what we can do about the other avenues that we have to talk to you. Thank you. So basically, I'll get started. A quick overview, like I said, some of the industry trends we're seeing. I'm sure you're aware. Increased interest to perform the basic and design and the production design to be accomplished in the same tool. So these areas, this work's not necessarily performed within the same organization and is frequently distributed within and outside the organization, as you're also probably well aware. That basically shorter design and production cycles are leading directly to shorter project payment schedules tied to milestones and deliverables. So we really want to compress the overall initial design, basic design, detailed to production design schedules. So we're seeing an increasing trend to want to do these in the same tools, or at the very least information flow between the tools. Hull really covers the part between initial design and basic design, moving from your concept to actual design and infrastructure. Time is money, but they also want quality at the same time. Some of the challenges of the industry. This brings me to another quick poll. I've just got 5 little polls here. Interested in understanding what tools that your business is using for the initial design. Thank you, everyone. See, everybody's voting quickly. Great. So I'll share those results with you. This is great to see. It's very consistent with what our expectations are and what our basic intelligence is. I would be interested for people who have chosen other, if they could send us an email or some other means, just in case, so we could understand what the other products are. Like the polls only allow for 5 selections, so I couldn't list all the ones that we know that people use. So I had to pick a short one. Wait, hide that one. Sorry, did I share that result? I'll just share that with you quickly. So primarily AutoCAD and Rhino, and that's completely consistent. We see a number of people are still using ShipCam, that's great, and the others about a quarter view. So I'd like to know more about who those products are. So what is ShipConstructor Hull? Well, Hull combines the purpose-built shipbuilding specific surfacing technology and the simplicity of working inside of AutoCAD, of course, ShipConstructor. This brings together the best of 2 worlds as far as we're concerned. It allows for easy and intuitive creation and manipulation of complex surface models. I'm sure some of you, there's always tricky situations that arise, as we know through our sport. Well, it also allows the freedom to use standard AutoCAD drafting techniques, of course. Looks like I've got a message here. ShipConstructor Hull features. The data design and the external hull production model flows into the structure production. Again, we support a variety of the products out there, the popular ones, as well as our own, of course. Go from initial design, capture the initial design, moving into basic and detailed design. So we can do things like section and mark trim existing surfaces, create new design surfaces. I'm not going to read this whole list. Today you'll probably see most of what's in this list. So we want to get to that demonstration portion, of course. A couple of the obvious use cases that we'd cover: initial design by separate organizations, teams, or software, as well as basic design and detailed design in the same organization. That's one thing we see a lot of that, to be able to flow the models back and forth throughout the design and production process. Another quick poll. I know many of you answered this when you first signed up, but I'd like everyone else to be aware of who else is attending. So do you use ShipConstructor Hull presently? Or have? So just for everyone's benefit here, looks like most of the audience today is using ShipConstructor Hull or has used it. So that's great. Thank you. I've got one more question. Have you ever attended an SSI training session on Hull, or I would say training session at all? We are always interested to hear how many people have actually attended training, especially one of the factors we see is when we visit clients that they may be using or trained on older versions of the product and they're still using older practices and aren't taking full advantage of the new functionality. Now this product hasn't changed a lot, but the product around it has, so there's always aspects of it that are upgraded. Great, I'll show that. That's an interesting result. Also not surprising. About half of you have not attended a ShipConstructor training. That's a real testament to the product. I think that people can be very productive with it with minimal training. And then the other training is somewhat dated. Well, with that, we'll begin our demonstration. As I mentioned earlier, it'll be Zoe Fife, and I'll just give me a moment here to hand it off to her. Okay, Zoe, it's all yours.
Thank you, Norman. Hopefully everyone can hear me. Hi, everyone. My name is Zoe Fife, and I'm a technical product manager here at SSI, and I will be speaking with you about the Hull module, as you're already aware. Hull is the gateway to the rest of ShipConstructor. It's through Hull that we're able to import design surfaces and extract the valuable information that's held in those to be able to produce other ShipConstructor objects, such as planar groups and expanded plates and the like. And that's really what I'm going to be focusing on today, is how quickly we can extract this information from design surfaces and produce some of these other valuable parts that we use in structure, that we can nest all the other works that are going on. So what you can see here right now is that we've got 3 different stages, in essence, of Hull. We have your setup, the modeling that takes place inside of Hull, and then the information that we export from Hull into other areas of ShipConstructor. I am going to start with today first off, we're going to import some surfaces, and we can do those from a variety of different file types. These can come from MaxSurf, Napa, Rhino, ShipCam. We already saw a pool of the different sorts of products that we can import from. Also, different entities based on those imports, so curves, meshes, NURB surfaces. And then what I'm going to demonstrate is how we can modify those surfaces, both on import and, again, once we've brought them into Hull itself. So let us go to ShipConstructor, and up here in the Hull ribbon, we're going to import some Rhino surfaces. Now, in the import window, we have this window itself can get detailed depending on the type of surface you're bringing in. So if you were to import a ShipCam surface, you'd get a different options in this case. When importing a Rhino file, we can also select a subset of surfaces, and that's what we're going to do here. We're going to select a few of them. We can show you right now that this is the entire setup from those 2 files, and this is what we're actually going to import. We can set what objects to import. We can choose whether we want to mirror the surfaces or not, and in this case we can set our tolerance, which is important because the NURB surfaces that we're going to bring in will be represented by a mesh surface, and so getting the tolerance, setting that tolerance, is important to balance the shape as well as the performance of what we see in ShipConstructor. So now that we've selected our surfaces, we'll hit OK, and then let's just set the viewpoints so that we can see them a bit better. So there we are. So right now we've got these 4 surfaces near the bow of the ship. And first off, what I want to show you is, now that we were able to do some modifications on that import, but we can also do modifications of these surfaces once they're in Hull. And we can do that by going to the Hull Surfaces section in the Hull ribbon. And we've got this button right here, Surface Properties, and we can open this up, expand it out. And so these are the 4 surfaces, and right now they're all just set up as surfaces. You can actually change them to solids which we'll do. We'll fill them all. And once you've done that, you can then also set them with a stock type. And by doing this, we now have, we'll now see that they have a thickness inside of hull. We can color code them. We can set ISO lines and see how that changes. All valuable information. In this case, I'm going to leave the ISO lines as none because we're going to be doing some other work. We're going to be adding mark lines and the like, and I don't want it to get too messy. And we can set the throw and the mark side of these surfaces while we're in this window. Okay, so now that we have imported those surfaces, I'm going to, let's see, now we can move on to producing. What we're first going to do is there's going to be 3 separate streams I'm going to take you down in this webinar. First, we're going to extract hull traces to produce planar groups. We're then going to do some plate expansion, and we're going to nest those plates. We're then going to create a stringer shell, and then create and modify twisted stiffeners. So first off, we're going to produce some planar groups. And in doing this, now that we've imported those surfaces, so we're going to extract a hull trace to produce the planar group. The extracted mark lines that we pull out are going to be NURBS curves objects, which have internally stored bevel information. So it's important in this case to keep that in mind because we want to retain that information. For instance, if we were to explode the NURBS curve objects to a polyline, we would lose that beveling information. So first off, we're going to cut sections to produce hull traces. We'll extract those NURBS curves, and then we'll export them. We'll create planar groups, and then I'll be able to demonstrate this automatic beveling, which is pretty fantastic because it means that you're retaining this information and you don't have to do that work again. In order for that to happen, though, before we actually go forward with all of that, we actually need to head up into Manager so that we can to do that automatic beveling. So go to Manager, into Structure, Plates, Bevel Settings, and we can see that there's this checkbox, Enable Automatic Bevels. Check this, and then there's some additional pieces of information that we can set, and but we'll leave that for the moment as they're already filled in. Hit OK. All right, so now we're back to our surfaces, and we can now cut some sections. In order to do that, we'll select the surfaces. We'll choose the 2 closest to the bow. And what we want to do is we want to add some surface mark lines. So in order to do that, there's a number of different ways that you can add mark lines. You can do it from sections, projection, girth, isostrain, isocurvature, and for the moment we're going to do it from sections. By checking this, it opens up location groups, and what we're going to do is we're going to create a new location group, and then we'll apply some. New. We're going to create a new frame. I'm going to call it half frames. And then we'll edit this location. These half frames are going to fit between frames that are already in the location group set, and they're going to be 600 millimeters separated, and they're going to be offset by 300 millimeters from the frame so that we can get a more complete set of these mark lines. So we'll go along the entire ship, in this case, or this section, and let's name them, because right now the name is the location, but that's not very descriptive for us. So we'll call them half frames. Go OK. Now we can see that they're named something that's a little bit more logical for us in this case. So now we'll select the frames and the half frames. Go OK. And we can see how they're set up. So once we've done that, now we want to actually extract the information. Kind of looks like a candy cane. Anyway, now we want to extract the NURBS curves so that we can produce those, the hull traces. And we can do that by going back to the surface mark line section and heading up to the mark line properties. And this opens up a window of all the information that's on these surfaces. So you can see here the list of frames that we've got. Now, this is quite a large list, and we could go through and we could choose to find the individual ones that we want and then highlight them again. But what I'm going to do here is show you how to also use the filter mark lines option, which is in the mark lines properties box. Makes it really quick and easy to choose the ones we want. So we're going to go down to half frame 106. Okay. And we can now select these. And we'll select them, and if you right click, you can see that there's a number of different options of what we can do with these mark lines. And so what we're going to do here is we're going to extract the NURBS curves. Hit OK, remove the filter, and then we will hide the rest of them, and now we can see that we've got those NURBS curves. However, they are independent. We've got two of them here. Just to show quickly, go to the properties. We can see that they say they're NURBS curves. So what we want to do now is go look on the NURBS curves section of the hull. We have a number of different options, ways that NURBS can be manipulated. We can create new ones. We can create them from objects. We can continue a NURBS curve. So if we had one but we wanted to extend it, we can split them, and of course we can join them. So what we'll do is we'll join these two that we've selected. We can set the tolerance of the length, hit OK, and we can see now that we've created a single NURBS out of the two of them that were there. Now that we have this single NURBS curve, let us go up to the structure ribbon and go to the utilities where we can then create a planar group from them. Go OK, get to name it, and what I'll do is I'll score this. Let's name it something similar to what all the other ones are already, and we can set some different information, the thickness, throw, the mark side. We'll leave that as it is. Go OK, and you can see here that this new planar group has been created. Now remember I mentioned the that we had that automatic beveling capability. So I'm going to quickly take you to that new planar group that we created. Let's open it up. And what will happen is when we open up this planar group, you can see it here right now, we're facing the bow. What we'll do is we'll create a plate, and then you'll see that automatic beveling appears. So we'll mark intersections, let's choose something, we don't need any frames. We'll choose a couple decks, and you'll see right away that it shows up on the draft cut. You can choose this information. Everything else looks the way we want it to. Go OK, and then create our new plate in here. Again, we'll leave the information because this is more about hull than structure, but you can see obviously you can set the pH position, all that kind of thing. And there you go. There's our plate with the beveling automatically included based on the NURBS curve information that we had from hull. Any questions?
Eric mentioned one thing, those curves are, the icons are very small. Are those resizable? I don't recall that they are.
I'm not actually certain about that piece. I haven't worked with those, so I can't say. We can look into that.
Sure.
So, oopsies. All right. So now what we've done is we've taken you down one of these paths of what hull is capable of doing. We imported some surfaces, we cut a section, we extracted the hull trace, and then from that we were able to produce a planar group that had the automatic beveling included. So next up, what we're going to do is do some plate expansion. In order to do the plate expansion, I'm going to actually have to split up that surface that's pre-existing. So we'll split the surfaces to fabrication specifications. So obviously the surface as it is quite large, and we don't have the stock necessary to be able to cut plates that size. So we're going to split those down into smaller pieces. We're then going to extract the forming information so that we can review the forming feasibility of the plates that we created. And then we'll produce nesting drawings. And the value in this, and the reason why I'm going as far as that, is that I want to be able to demonstrate the interconnectivity between hull and the rest of, and these objects that we export, that we bring into the rest of ShipConstructor. So when we bring these parts into structure and then nest them, there's still this relationship retained between the hull design surface and these parts, so that we can go back to hull, we can make modifications in hull, and we can push all that information forward. It reduces the need to repeat activities in different locations, and it ensures that information that is set up initially is retained all throughout the design process. All right. So let's delete this NURBS curve because we don't need it anymore. And now what we want to do is we're going to select these two lower surfaces. We're going to go back to hull, and we're going to cut some new sections. And this time we're going to do some unit lines and some water lines. So here we can see we have some unit and half units and some water lines that go along. And what we want to do is, or what I'm going to do or demonstrate for you, is that we're going to split up one of these surfaces. We'll split up this one right here, and so that we can then expand it as a plate. So in order to do that, up in the hull surfaces section, there's a split surface button. So we'll run this. And we're going to cut some mark lines. Oops. Before we do that, though, one thing that I need to do is when you choose to run split surface, you can see down here that you can, at the bottom command line, that you can either choose to do it with mark lines or with surfaces. And in this case, we want to use the mark lines. So we'll select this mark line here, enter, see how it cuts it up. Then we'll do this one, and then we can use that half unit. And now we've got this new surface. And in fact, just to differentiate it, we can go back to the surface properties, and we could give it a different color, make it blue. Because earlier on we had changed the stock of that entire large surface, even when it's split out, it retains that stock. Great. And then we'll close that up. So now we've got our surface. We could go to conceptual mode, and we can see how that surface, we can see how the surface differentiates from the rest of those surfaces that we have. And so in order for us to expand the plate that we've now created, there are a number of options that you can set when running it. Because there's so many options, but they're also oftentimes kept consistent from one surface to the next, we have an option up in the hull surfaces to set the global expansion settings. So I'm going to do that first, and what happens is once you set all of this information, you can then apply it to all surfaces, and then And then that way we can ensure consistency in what the forming templates are going to look like, or how these surfaces are going to be expanded, so that we can maintain that in the fabrication for later on. It also means that modelers, if they're doing other work and maybe they're not certain about what the information is going to be in here, that can be preset for users. So in this case, we have our expansion options, and here the auto setting indicates that ShipConstructor is going to choose the optimum direction of expansion in order to reduce strain. You can also choose your own if you want to manually override it. We've got different position information, roll lines, in this case we set to dead rise, forming controls. So we're going to add the forming controls, we're going to draw those on, and we're also going to place them on the plate so that that way they could actually be included in the plate rather than just being in the drawing in case people wanted that information for another situation. Won't change any of the information to do with stock. This has to do with adding green and the like. We'll leave all of this alone, and we can go into more details on these at another date if people have specific questions. The forming templates is an area that I want to add some additional information. There's a number of different labeled information we can add, and you can see that everything is checked off. We're also going to check the show on plate surface. What this will do is that not only will it create the forming templates, but it'll actually add them to the curved surface so that you can get a better visualization of where they're situated. We're going to set them as auto leveled. This is an option that I choose to use in this case. You could add additional frames like other mark lines, and inside of the mark line properties you can actually set them so that they can be used as templates in this situation. But here we're going to auto level them, and you can set the option of the number of templates. We're going to keep it small in this case, and the edge distance, which is the distance that they'll start from either edge of the plate. We're going to leave them as plate type, although you could make them strip if you wanted to, stack strip, but we're going to set them up as plate in this case, and we're going to create a sightline template. And we'll set the minimum height of the template. And then we also have an orientation icon that we can add. Ensure that I've added everything as I want to. Oh, we want to make this large enough to be visible. And that should be everything. Okay, so we'll apply that to all the surfaces. Go OK. And now we're going to actually expand this plate. So we'll select the plate that we want, go back to that location we were at in the hull surfaces, and we will select Expand Surface. This area right here talks a little bit about, it gives you the opportunity to look up more information on how to extract this as a curved block or extract it to ShipCam, or export to ShipCam, I should say, and discusses, it also allows you to find out more information about this whole expansion in specific directions. We're not going to go into details about this for the moment. Again, if you have questions, please feel free to ask. And we'll continue this. You can see that the exact same window has opened up, and all the settings that I previously put in are still there. So I could change these if I wanted in this one specific case. We can also see that the surface has changed slightly. A mesh has been added, so we can actually see what the mesh looks like, and you can see that there's a green and a red arrow. These are in reference to the expansion options. So the green arrow is the direction that ShipConstructor has chosen because we auto set it, and red is the other direction. For this specific plate, the direction of strain wouldn't change very much. So if we chose to do it, if we chose to expand in the other direction, there wouldn't be a great change. But there are times when the green arrow is quite tiny compared to the red, and it's something that should be taken into account when deciding to override what ShipConstructor suggests. So go OK, and here is our expanded surface. Before I go and look at it, I want to show you again down here. remember that I set it so that the forming templates would show up on the plate, so you can see exactly where they appear in each case. And then let us go look at what we pulled out of there. We can start, in this case, let's start from right to left. Okay, so this is our sightline template. And it also, because of how the, because we set the plate style forming templates will slot fit into the sightline template. And so we can see where each of these will be set up. There's also information about each of the forming templates. This is all the detail that we requested that be included in the labeling. And then over here is our plate with all the forming controls. Now the additional forming controls are there to help. They're in essence kind of like a quality assurance type of piece of information, so that when we add, so you use the forming templates to form this plate, and then the forming controls can be looked at to ensure that the plate was actually formed as expected. Perfect. So now that we have this plate, we're going to export it to Structure so that we can demonstrate how quickly and easily we can do that. So we'll export it to Structure, and then we'll nest it. Let's set this back up to another viewpoint, make it a little bit easier to see in this case. In order to export the surface, we go back to the hull ribbon, and in the hull ribbon, under Hull Surfaces, there are, oh wait, before I do that, I forgot, I want to show you this train. So before we export it, we want to test this surface, this plate that we've expanded, to ensure that it doesn't show an unacceptable amount of strain. We can also create a deformation table, but right now what I'm going to do is show you the strain in this case. So you can choose the plate, hit enter, and we'll apply this. And you can see that there's a strain map. We can set what the max and the min is going to be. We set it to be 0.5 to minus 0.5. And in order to be able to see this information, we go back to conceptual mode. And we can see that in this case, it's a pretty nice set of green. If you go down here, you look in the corners, you can see that certain pieces of the mesh have gone to a darker color. So it might not be completely certain right off if this plate has an acceptable amount of strain. So what also is available to you on the strain map is this checkbox of strain beyond range. If we check this and apply it, we can immediately see that everything that's within reasonable, that's not above the max or the min, is set to green, and immediately it cleans up. And we can see that this plate we've split out of the surface is reasonable and should be fine for fabrication. Let's see. And as I mentioned, we also supply a deformation table. I'm not going to create it at this moment. And that gives information across the total length of any one line on the surface versus this strain map, which gives the difference in surface area at any given point on the mesh. And that's why you could see the individual squares when we did the strain. And now now that we see that we've created a reasonable plate, we're going to export the surface. So export the curved surface, select it, enter. And I previously created a file where I want it to go. So this is a curved structure file drawing. And I also, this just lets us know that some of the mark line style information isn't available on the structure drawing, which is okay. What we can do here is we can change any of the information we want. So we'd already had previously set the stock, but this gives us the opportunity to modify that if we so choose. We can also set the product hierarchy to be a certain value. Here we already, what I did when I created the structure drawing was I preset the location of the pH, so any part that is added to this structure drawing that's exported to it will automatically go to a certain location in the product hierarchy. This is valuable in that it reduces that question later on, or the forgetfulness. The reason why I did this was because the first time I went to try to nest this plate part, it told me that it couldn't nest it because it wasn't in the product hierarchy. And so in order not to have to go back from that type of situation, I went and I set up my structure drawing with a preset product hierarchy location, and that way I don't have to worry about it later on when I go to nest. Okay. One curved plate was created from surface, and we can now go and open that drawing. I'll head down to it, open it up. And now we can see these. So the curved plate, the expanded plate, and the forming templates. You can see that the curved plate, expanded plate, forming templates are all loaded into the structure drawing. And these are linked to the curved surface and hull. And this is very valuable, and I'll demonstrate how this is useful. And so, because what it means is that any changes that are made in hull can then be made in the structure part. And that also means that we can leverage the sort of changes that would happen in hull. And so once we've done this, I'm now going to close this drawing. And I'm going to open up a nest drawing. So I mentioned earlier on that we use stock PL10, so I'm going to put this in our PL10 nest drawing. And I'm going to create a new nest. It automatically generates a name for me. I can choose my stock size. In this case, I'm going to use a smaller one and a template. So I'll create this, add it in. And now I want to insert that part that we just exported to structure. So we'll go down to that location in the product hierarchy, and we can see that our curved plate part is there. I won't go into the details about the different pieces to do with the nesting, as this is a hull webinar, but again, if you have questions, please ask them and we'll see if we can help you out. Here's our part, and there we go, we've nested it. You can see up here that there's some information about this plate. There's no NC information because we haven't assigned one, and there's nothing in the BOM. So if we run update, we can select that nest. It'll update it. And now we have the plate part included in the nest. So I'll close that up. All right, but what if our hull drawing changes for some reason, our design surface changes, and we want that information to work its way through to that structure part that we expanded to that nest that we have. This is really one of the areas where hull demonstrates its value. We realize all of a sudden, oh no, we didn't put our bow thruster in. So inside of hull, we are going to import a new surface. Same, you can see it's the same import instruction. And let's go to conceptual so you can see where it's cutting through. And you can see that it's actually cutting this plate that we've already expanded and exported. So we need to modify the plate. In order to do that, what we will do is we will split it based on this new surface that we've imported, and then you'll see how the modifications to this plate can easily be transferred to all the structure parts and the nest itself. In order to do that, we're going to use this intersect surfaces command that's on the hull surfaces, and what it will do is it'll produce a mark line between where these two surfaces intersect. this one. We're just going to add the mark line, in this case, to the plate. So we'll hit OK. Delete this. And now you can see that there's that line, the semicircle that we've created. And based on that, we're now going to run the split command again. Use that. We still have it as mark lines. That's fine. Hit Enter. Now, this is important. As I was saying to you, there are linked, like this surface is linked to other parts. And so this is warning you that there might be unexpected results. You could, if you wanted to choose, you could choose to break the link. In this case, we're going to ignore it, and we will move forward with retaining that relationship. Now you can see that there's two separate surfaces. And what I'm going to do is I'm going to select that surface. Oh. Doesn't seem to have worked. Hold on. Let's do that again. Might have been too quick on it. Sure. Ignore. All right, there we go. Perfect. I'm going to select that one, and I'm going to hide it. And now you can see what our surface should look like. So now let us go back to 2D wireframe mode. Let's go to that expanded surface. And what we can see, actually let's go back to what conceptual so we can show it to you better. What you can see is we kind of have the wrong shape. We have a semicircle. We don't have the expanded plate that we expected. What's happened here is that the relationship between the expanded plate and the curved surface is a one-to-one relationship. By us splitting that curved surface, we've forced ShipConstructor to choose one of those surfaces to retain the relationship, and it's chosen the one that we don't want in this case. So it's not. What's nice about this is that it does not affect the it doesn't affect the relationship that we have with the structure drawings or anything else like that. So what we can do is we can delete this. Yes, there we go. We can delete that. We can run the expansion again. Once again, we'll do it with all the same information. We see that it looks the way we want it to. And now what happens is we can update the structure part, and it will respond as expected. So inside on here with our hull surfaces, where we had before earlier on exported the curved plate, we're now going to update that curved plate. We choose a surface. It asks us which one, and that is the plate part that we're interested in updating that was in that the structure drawing that we'd created. Okay. This is also important. Hull's effects will overwrite what's been done in structure. This goes back to something that Norman mentioned earlier on in his part of the presentation, that we really want to get the majority of that design work done when we're in Hull, because any work that we do in Hull can then just be pushed through to the structure and to nesting without a lot of extra work in those other areas. And so this is what this is saying, is that by doing all this work in Hull, we're then going to overwrite whatever might be in structure. So it's just important to recognize that. Okay, once again, gives us all these options so that we can modify it at this stage if we want. We're not going to. And then, save that for right now. We'll open up that structure drawing again, and we can see that it's been updated. And then if we go to the nest drawing, you can see that we're immediately notified that a part has been modified and that it needs to be updated. So we say OK, and just like that, it has its new cutout. So we've been able to very quickly go from importing that surface in Hull, splitting it up, expanding it, exporting it, nesting it, and then modifying it and going through all of those all over again. Perfect. Let's see. There are some questions. Let me just take a moment. So one individual asked if they can modify the seam split. What is happening right now is if you're reducing the size of your curved plate part, it's relatively easy, but it takes a bit more work to increase the plate size. So the answer there is yes, but there would still take a little bit of work to make that happen. As for there being plans to add the templates directly as part with a relation to the expanded plate they belong to. So one of the questions has to do with the forming templates and the fact that those forming templates are there, but at the moment you can't automatically take those forming templates and nest them, but it is possible to, because we have the geometry there, to produce plates from that geometry and nest the geometry. We are intending to move forward that in the future, though, because we recognize the value in being able to nest those forming templates. And now we've created hull traces or exported the hull traces to planar groups. We have expanded plates and into structure and nested them, and now we're going to create a stringer shell. And from that stringer shell, we will create a twisted stiffener. Okay. So first we'll create a stringer shell, and these are created from parallel section curves, and that makes it easy to model the stringers so that they can span multiple surfaces. Once we have that stringer shell, we can create a stringer, and then from that, what I'll demonstrate is how, once the stringer is created, how we can define it, we can manipulate it, and then what we'll do is we'll export that stringer to structure, and then again demonstrate that relationship between objects in hull and objects in structure in the rest of ShipConstructor, because what we'll do is we'll go back to hull, we'll modify the stringer in hull, and we'll show how that modification of the stringer immediately impacts this twisted stiffener. And then we will also show how this twisted stiffener integrates smoothly with previously modeled parts. It's recognized today that we don't always add the stringers right at the beginning of modeling, and so it might be that frames have been built up, there's plate parts pre-existing by the time that stringer is modeled, and in which case it actually is intersecting previously created plate parts, and we want to demonstrate how quickly we can produce a cutout from that situation. Okay, so let's close these up. We don't need them right now. So what I've opened up here is a single surface that spans more than one unit, and it already has pre-existing frame, water lines, and buttocks lines in it. So we're going to go back to the mark line properties box. It's these mark lines that are used to produce a stringer shell, and so what we're going to do here, what I want to demonstrate for you is that let's hide those buttocks and water lines, and then we'll show the frames. So these are just the frames on their own. What I've also created is half frames and quarter frames. So I'm going to highlight them. So you can see how this is quite a well-defined surface now. The purpose of doing this is that the stringer shell's form, its smoothness of fit, is dependent upon the extracted NURBS curves that we get from these mark lines. So the more curves that we have, the better defined our stringer shell will be, and in fact, the better defined our stringers will be for modification and the like. However, in this case, the larger number of points also, or the larger amount of information in that surface, in the stringer shell, also means it takes a little longer to export the stringers and to update the stringers. So in this one situation, what we're going to do instead is we're only going to, let's see if I highlight all this stuff, we're only going to use 2 of the sets of mark lines that we have. So we're only going to use the frames and the half frames to produce our stringer shell. So what I'll do is I'm going to highlight all of these inside of the Mark Lines Properties box, and I'm going to extract those NURBS curves like we did last time when we were creating the planar group. Go OK. And now we'll go back up here and we're actually going to hide that entire surface. So now that the whole surface is hidden, all we see right here are the NURBS curves. I just want to mention at this point the value of this Mark Line Properties box. You can see how quickly we can manipulate the mark lines and the surfaces themselves, how we can use this information to create NURBS curves. And I'll actually quickly just highlight for a second. Earlier on, I'd mentioned that we auto-created the forming templates. It's here. If you were to select one and say toggle as template, this is how you could use one of these mark lines to create your forming templates as well. So it's a very valuable window. Definitely spend some time playing inside of there. So now that we've created, now that we've extracted our NURBS curves, we're going to select them all, and we're going to go up to this section in here in the hull ribbon on stringer shells, and we're going to create a new stringer shell. Sorry, water break. All right. So as I mentioned earlier, the more data points that we have, the better defined that stringer shell is. However, you notice that when we had all of the mark lines, all 3 types listed, it was very messy. What we saw, maybe messy is the wrong word, it's very detailed, and which means that trying to then add stringers or do the like could become potentially complicated when we're trying to do our modeling work. So we give users the opportunity to change, to determine which of these NURBS curves will be used for control sections and which ones are going to be visible and which one will be invisible. A control section, you can see, I'll show you the list right here. A control section is a point where a stringer can be manipulated, and I'll show you a little bit about that when we've actually created a stringer. If we set the section type to visible, it means that it will show up on the stringer shell, and it will obviously be a data point as part of that stringer shell. However, it's not a point of manipulation. And if we set them invisible, then you won't see it any longer. However, once again, it'll be used in defining that that stringer. So what we're going to do here is I'm going to set all of the frames as control sections by highlighting them and then filling the types. There we go. And we're going to leave all the half frames as visible. Now, if we'd retained the quarter frames, we would have set those to invisible. But like I said, in this case, this is just in order. Because it's a demo, we want to be able to move quickly through it. So we say OK, and there is our beautiful stringer shell. You can right-click that, go to the properties, and you can see that it's a ShipCon stringer shell. All right, so let's put this in a bit of a better shape for when we're about to make a stringer. You can see it you can see the actual curved surface of it. There we go. Ooh, let's make a stringer. Who wants to make a stringer? Oh yes, of course, all of you want to. Okay, so we're going to make a stringer from girth. Go back to hull, the hull ribbon, and we see that there is another section all about stringers. And there are a number of different ways that we can create stringers. You can create them from projections, polylines, girths, or reference lines. And as I said, today we're going to do them from a girth line. So we're asked to select our stringer type, our stringer shell. We can set up our girth function to be from the surface edge min. Go OK. And we can see that we now get to choose a location for the girth lines, where those lines are going to show up. We don't have any, so we're going to have to create a new one. This is going to be a fixed girth. There's also proportional ones. We're going to name it stringers. We're going to edit the location. What I've done there, by setting the from position, the to position to 1000, what I'm in essence saying is that I want constant girthing so that we set, so that both the start point and the end point of these stringers are at the same position along that surface, starting from the bottom of the surface. And then we're going to set each one to be 1000. Let's do a few of them. Oh, and let's change them to a pretty pink color that we're not going to see. And in this case, we're just going to leave the name based on the location. OK. Now, immediately upon choosing that location, we're now given a new window where we can set pieces of information about those stringers. Now, we can't zoom in on this right now, so I'll have to set all this and I'll show you about it afterwards. Going back to that pretty pink. OK. Here we can choose to modify a single stringer one at a time, or we can set all of this information and then do apply to all afterwards. What I want to do actually is I'm going to apply all, and I'm just going to set that, and then I want to zoom in because I actually want to show you what we're doing in this case. So here we can see that we have all these stringers that have been set along girth lines. I now want to select one of them, and we got up here, we have a stringer properties window, and this will just open up the exact same window that we saw, but I wanted to just show you what's going on here. So if we do an attach to, what we're doing in this case is by flipping this, we're actually changing the side of that surface that we want to attach the stringer to, or soon to be a stiffener. And we can also change the toe direction. So you can see how, once again, it's a little faint, but we're actually switching the direction we want it to be in. We can view the stringers in different ways. So this is your profile mode. We've got angle mode, line mode. And then we can also set information about how the stringer, like what the angle reference is for the stringer, and different pieces of information. And I'll do that in a moment. But I just wanted to show you some details about how we can manipulate those. So we have stringers. They're not twisted. I know they're called twisted, but they aren't twisted yet. So let's twist one of them. Let's twist the top one because it'll be the most interesting. Let's zoom in on it again. Oh, remember when I told you about the control sections and the visible points? What you can see here is you see how there's these blue squares and these pink X's. The blue squares only show up on a control section point. So you'll notice that this would be considered, that's a visible point, the white one, and the blue one, the blue line there is a control section. And then the pink is just telling you what the endpoints are of those stringers. So by selecting these, we could actually do some funky stuff by modifying them. And we will modify one in a moment, but you can see that how obviously I can't select a point here where that visible is. And so that's one of the major differences between setting some points as control sections and some as visible. So now let's select what's already selected. We'll go back to that stringer properties. And what we want to do is we're actually going to twist it. I love this because it does it so smoothly, and it's pretty cool to watch. So what we'll do is we're going to set this endpoint that we can see here as a horizontal angle reference, whereas the original one is, like all the others, are set normal to surface. As soon as we did that, it changed its angle. So we're going to set that to 0, and you're going to see a pretty extreme directional change. So you see how right now it's angled harshly. So we don't want that to happen. We want it to be more smooth. So what we'll do is we're going to select all of these points now. We go back up to the angle and we say evenly distribute angle between. And by doing that, it sets the information so that we have a clean, smooth twist. And you can now see how well that twists along. And I guess to get a better view of it, let's see if we can set you up with a better view. Let's play with the 3D viewpoint for a second and see if there's a better view that we can show. Is that going to show it? Doesn't show it as well. So what you can see here is you can see that the angle is one there, and then how it twists itself into a new type of angle from there. So we have our stringer, and now what we want to do is we want to export that into structure so that it can actually be used. So let's select it. We'll go back up to our stringer section, and here you can see that there's a button called Export Stringer. Click this, and it will ask us where we want to put it. I've chosen a structure drawing in Unit 1. So what we're going to immediately see when we do this is that Unit 1 shell is a number of curved plates, and because this surface that we've modeled the stringer on is longer than a single unit, we're going to see that it's going to expand further. We're given an opportunity here to change information about this stringer at this point, so we can change its stock, we can set its location in the product hierarchy, any of the types of settings that we want. For the moment, we'll just leave it. And as I was saying earlier, the reason for why we didn't choose as many data points for making the stringer shell is because it can take a moment for us to export this to structure. And so now that we have this, we have a second here. Let's see if there's any questions that we can answer. Okay, so, actually, I haven't seen, not seeing any questions specifically to what I'm doing at the moment. So let us just go now to the drawing that we exported this to. All right, so in structure, we brought it into the shell drawing. We're going to open this up, and you can see that this looks, well, I shouldn't use the word silly, but it looks extreme. How's that as an answer? I mean, as a description. So let's put this over here. You can see that from an extreme case that it is, that's showing up. Oh, we have an extra one. Let's delete that one. So you can see that we've got this stringer that we've exported, and it goes quite far off of this shell, but it gives you an idea of obviously what would happen when we're modeling these stringers that go across units, and the value in this, because it gives us an idea of where it's fitting. Now that we've done this, we're going to close this up. Save that. Take this, and now what we want to do is we're going to modify it. So we'll take this and let's stretch it, and we'll just do, again, something pretty extreme, just so we can see that. Save it. And then back in our hull drawing, we have a button that says Update Twisted Stiffener Part. And so it's giving it, what it'll do is, by selecting this, we select our stiffener, and it automatically selects that part that it was originally associated with. It retains, again, that relationship between hull parts in hull and parts in structure. We'll go OK. Once more, we get that reminder that if we modified this part in the structure drawing, that we're going to end up potentially losing that information because we're really pushing this information from hull into structure. once more, we have the opportunity to change any of these values. I find this really useful because it means that if at any time we realize that we want to be able to change some of this modeling information, anything that's going on, we're given these opportunities to do it. And then it will run that update. So one question we have is how did you add the stringer to the shell plate part? So what happened in this case was I'm guessing that, okay, what I'm looking for here, so I'm thinking that that's the relationship then, you're asking about the relationship between the plate in the structure drawing and the stringer. And I'm not totally certain if that relationship is, if there is a relationship between them. I don't think there is, but I'm going to wait and see if if Kevin has a better answer for that. An individual asked how to split the stringer if we want to. The stringers can be cut or split with native AutoCAD curves. And so that you can actually, oh, there you go. So hull stringers, yeah, so the stringer can be cut or split with native AutoCAD curves splitting functions in hull. So that's one way that you can split it. And the stringers in hull are based on polylines, so that's why you can just split them that way. And let's just go back to save all this stuff. Let's go back to our structure drawing. And we can now see, let's put this into conceptual mode so we can see it. We can now see that we have got this same extreme change to that stringer that, well, I guess here, the stiffener that we had done inside of hull. So we can modify the twisted stiffeners from hull, but what about the fact that we've added them into this project that already had pre-existing plates, pre-existing parts? I'm going to show how we can very quickly create a cutout. So once again, we're going to open up Navigator, we're going to go to Structure, and we will extract a planar group. Okay, while that's happening, so it realized, so I misunderstood the question. There was a question of how do you add the stringer to the shell plate part. So that's actually in hull. The way that it was added was we produced, like you can do it based on girthing, projections, polylines. We create, you set up where you want those lines to be, and then the stringers are produced from those lines that you create. So all right, so here's our frame. And what we want to do is we're going to M-link in that shell that we have that contains the twisted stiffener. And zoom in on it, and so you can see how it obviously intersects this plate part, and which means that we need to properly create a cutout. We can do this quite quickly, in fact, by selecting the plate part, and if we go back to Structure, then under Structure, under the Plate section, there's a button called Manage Cutouts. You click Manage Cutouts, and it immediately pops up knowing the stiffener that's causing that interference. And it knows the cutout type because that was pre-assigned to the stock of that stiffener, and the information about it. We hit OK, and there is our cutout. If we modify the stiffener in any way, then this the structure, like the relationship between the structure part and the stiffener in the sense of this cutout, will respond. They'll recognize that there's been a change. So if you change the stock to the stiffener or whatnot, then ShipConstructor recognizes that and warns you and handles that in a smooth fashion. And that is us having gone over twisted stiffener. So we created a stringer shell from extracted NURBS curves. We create a stringer then using girths, and we exported that stringer to structure. We modified it in Hull and demonstrated how it has retains that relationship with the structure, and then also showed how doing this later in the project is still acceptable because we can fit the parts together by doing such as like creating extra cutouts. And that is the many facets of Hull that I have to demonstrate for you today. Any questions? Let's see. I'm going to go back through the list and see if I can answer it.
Yeah, we got one in there.
Yeah, like so there's the, going back again, was the stringer, which was created from a stringer shell, automatically assigned to the shell plate in that area? No, it wasn't, because the stringers can cross these unit boundaries in other areas. They don't retain that direct relationship with the structure part, like the shell plate structure in that case. Anything people want me to go over again? I know that was a lot of information supplied. While I wait for some questions, the one thing I really want everyone to take away with them in this webinar is just how interconnected and powerful Hull is. You know, the ability to be able to import these design surfaces and extract that information to then push it into these other areas of structure so that you don't have to model that again later on, and to retain those relationships is so valuable because it reduces the questions that would happen later, or even the inconsistencies, because what we would then do in Hull, or you know, a design surface might change, that information can then get pushed through to the rest of ShipConstructor. It's quite powerful, and I hope that this has done something to demonstrate that for people. One person has asked, can we offset surfaces in Hull? The answer there is yes. And can you add mark lines to these twisted stiffeners to the Hull surface? I'm not totally certain about that. I'm going to again wait for our expert. Ooh, I have an answer. Yes, but it's outside the scope of this webinar. You can extract curves from the stringers and project them onto your plates. So, oh right, of course, I remember that. I've done that. So you can, yeah, so you can actually use those stringers, extract that information as curves that show up on the plates, and by projecting them onto there, you can then produce them, like you can then use them as mark lines.
That's great, Zoe. Thank you. I can take over and just have a few wrap-up slides if you like.
Perfect.
And of course, people can continue to submit questions. We'll answer them while we're still online. And we've also got our means to ask questions afterwards. I'll highlight that. Am I showing the correct screen? So just to conclude, we've just got a couple wrap-up slides here. Some of the key takeaways we want to make sure I think people have picked up, and Zoe's done a good job of highlighting the main things. And capture design data from the initial design, section mark and trim surfaces or capabilities. So we didn't see all of these capabilities, but we'll just highlight some of the other things. Create new design surfaces, of course, fair surfaces to production detail, analyze the curvature, create and manipulate shell stringers, expand production quality plates, create forming templates, analyze strain, send pieces to structure for production, and pig jig drawings, of course. Some of the main benefits from it: to retain this flexibility, no real limits placed on the choice of initial design tools. We have a number of ways to import them in. ShipConstructor provides the ability to import data in various industry standard formats. As you saw in the survey, AutoCAD and Rhino are certainly the biggest ones. Data created in whole can seamlessly be utilized in structure. So this is a very important aspect, of course, connected to the whole solution. Just in terms of product availability, very quickly, Hull is a associated product with our structure product. So structure licensing is by parts, part counts in our modules, and you can add Hull to that. But we also include suites. So suites are really intended for small and medium-sized organizations that have medium to large projects. That tends to be where the numbers work out best. Again, if we've got any more questions, now's a good time to answer them. If you don't, or you want to ask them later, we would like to raise your attention to the Augie Marine Forum. So it's a public forum. It's not ShipConstructor unique. It's about the marine industry and shipbuilding. You can certainly fire up some questions there, and we do monitor that and contribute to answers along with everyone else. If you are a client under subscription, of course, you could submit your questions to us through Nexus, Nexus account for your company. And of course, if you have any broader questions about product availability or licensing or whatever, you can contact your local dealer. One of the things we've been doing over the last couple of years is really expanding our social networks. Really, it's not just a one-way pathway to send information out. We really want to engage with people, engage with our clients in the market. So I'll leave this screen up here for a bit, capture it. There's quite a few different options now where we're publishing information about what we're doing, what we're thinking about in the future, as well as just questions and answers about our product. We, as part of this series, the next one, surprisingly, is ShipConstructor Structure. It's a natural. Structure offers rapid 3D production detailing of internal hull structure. Based on the audience today, we've already got at least as many people registered for the next one, so it's very good sized audiences. When is that? It's July 8th, 8 to 9:30 a.m., so same time on a Wednesday in a few weeks. The topic has been posted on the Bulletins project, so I see a number of you registered through there, and you've probably received an email already from our SSI marketing group, but please feel free to forward those registrations to others. It's our open sessions. So one last final poll. Let's, bear with me here. Did you find this webinar useful? Happy to see most of you are still attending. Just letting the votes come in. I hope you found it informative today, and as I said, it's an ongoing series. If there's different angles you want us to emphasize more in the future, also feel free to suggest those kind of things, upcoming topics. You're certainly welcome to submit ideas for structure, the things you want to see, so just give us a buzz. So I'm glad to see most of you found it useful. Okay. And that concludes our session for today. Hopefully everyone's got the answers they wanted, and you know how to ask them. Yes, I've got a question here. We'll be publishing the recording. Yes, we have been recording this, and we will make that available. You should see a posting or notification for it in the next couple of days, and that'll be available. Feel free to forward links to others. It is hosted by the GoToWebinar site, so they will have to enter their email address when they want to review the video, but it will be made available for everyone. Thank you, everyone. Have a good day. You're welcome.